Well, I guess we're ready to go. Hey, good morning. Hey, this is Tuesday, March 31st. So glad to have you back. You know, we've been talking about geometry and our introduction to geometry. Let me just review a little bit. First off, I wanted to tell you that we learned about, in geometry, they have what's called a line. That reminds me of God because there's no beginning and no what? No ending. So if anybody ever says, I can't believe in anything that doesn't have a beginning or an ending, well, just tell them, what about a line? All right, it's in geometry. All right, Ray reminds me of people. Has a beginning but no ending. A segment reminds me of animals. They have a beginning and they have an ending. Sometimes right on my plate, yeah? And then point, they have, well, we use capital letters when we name points. And so we also learned about a plane. It's a flat surface. Parallel lines that would have this special symbol in order to represent lines as being parallel. They never meet if they're on the same plane. Intersecting lines are lines that meet, and they meet at a certain point. So we are now moving on to what we call angles. And today, 9.2, we're going to talk about angels. We're going to measure angels. We are going to draw angels. I'm sorry. No, we aren't going to be able to do that. You know, angels are really wonderful and great to talk about. And I'm not downplaying angels. But no, this is not about angels. It's about angles, right. 9.2 is talking about angles. Let me define an angle first. An angle is when two rays with the same endpoint form an angle. So here I have ray QP and ray QR, and right in between, this is called the angle that they form. So you have two rays with the same endpoint, they form an angle. Now that endpoint where they share this endpoint, that's called the vertex. So you must know that term because that's an important one. The vertex is the shared endpoint of the two rays that form an angle. Now there are three ways to name this angle, right? And you need to know all three. First off, I can name it using the points. Angle PQR. Now notice the symbol for angle. It looks like a nose, right? Make sure when you draw it, it looks like a nose. Don't draw it like this. Don't draw it like that. Put it down, and there's the nose. Right there. No, we won't say what's in the nose, but that's angle PQR. I can also call this angle RQP. Angle RQP. Or I could call it just angle Q, which I think is the way you would most likely want to do that, right? It's the simplest way. But you notice that however I write it, when I use all 3 points, the Q or the vertex, in this case it's a Q, the vertex has to be in the middle of the name. Always. You cannot put the Q at the end or the beginning and name that angle properly. It always has to be in the middle of the 3 letters. The Q is the vertex. So, I like to, before we start measuring angles and drawing angles, I want to make sure that you have your protractor handy. Put this on pause and go get your protractor if you don't have it right now. Ready? Go. No, I'm just kidding. I'm not on pause. But I hope you're back now and you got your protractor with you. Now, there's my huge door protractor. I mean, it's for the board, right? So the board protractor that I use, I want to tell you, first off, something about protractors pretty cool about it. They're used to measure and to draw angles. That's what we're going to do with this. They're going to use measure and draw angles. What are we going to do with this? We're going to what? Measure and what? Draw angles. That's what we're going to do. Well, first off, you know, a protractor comes from this idea of a circle. You know, I think it's the Babylonians, or way back then, they thought of everything in the term of 60. That was their most important number. Why do we have 60 seconds in a minute and 60 minutes in an hour? We still inherit some of those things that they did in ancient days. 60 was important. Well, 360, when they divided up a circle into what they call degrees, they decided to put 360 degrees in that circle. So if I go here and there's 0 degrees, and then 1, 2, 3, 4, 5, 6, 7, I get up to 90, right? And then I go, and I'm facing that direction, it's 180, and then 270, and then I come back 360, it's the same thing as 0 again. So when they divided up a circle into even parts, they're called degrees, they decided let's put 360 of those degrees in a circle. Well, you'll probably notice that your protractor is half a circle. Right? It isn't the whole circle, it's only half a circle. And since it's a half a circle, a half of 360 total degrees in a circle, a half is 180. So you'll when you look at your protractor, you see that it goes from 0 to 180. And that's not just random, it's because it's half a circle. If it went all the way around, there would be 360 markings. But they only needed 180 because it's half a circle. Now I've drawn a protractor up here on the board, and yours might be similar to this. Some important parts to it. First off, many of your protractors, in fact I would think almost all of them, have two scales on them. And don't be confused by those. One is the inside scale, and it starts at 0 on the right side of the protractor, and it numbers all the way degrees up to 180. And that's called the inside scale because it's inside that half circle. Then you have, guess what that's called? You're right, that's the outside scale. The outside scale starts at 0 on the other side of the protractor. It starts at 0 on the outside scale on the left side of mine. And it goes from 0 all the way up to 180 this way. Same number of degrees, same markings, but they start at 0 on this side, and the inside scale on the right, and it goes to the left, and it starts on the outside scale on the left, and it goes to the right. It's two different scales, but don't let it confuse you. It's very handy when it comes to measuring angles to have those two scales. All right, so that is a protractor. This is a very important part of your protractor. You have either a hole right here, just about here in your protractor, and don't take it back because something's wrong with it. That's supposed to be there. That hole's supposed to be there. Or you have what I have in mine, and it's a notch. Now, we heard of the stromboid notch when we talk about Florida fighting cocks, but that's not a stromboid notch. It's called the vertex notch, because that notch is where I place the vertex of the angle when I measure an angle. Well, let's practice measuring some angles here. First off, I'm going to start with finding the measure of angle A. So here's angle A. First step is I take the protractor and I just choose one of the rays. Now, Mr. Frazier always chooses the ray that goes parallel with the ground. In other words, I choose the ray that's horizontal. That's just, that's the one I want to choose first. So I put the vertex here, A, right there in the vertex notch. And then I point the ray that I chose, the one going this way, at 0. You see, the ray that I'm pointing at reaches 0 right here. Now that's on the inside scale of my protractor. That 0 is on the inside scale. So I start at the inside scale, 0, 10, 20, 30, 40, 50, 60, 70, 90, 100, 110, and the other ray intersects my protractor at 120. Again, I'm using the inside scale because this ray starts at 0 on the inside scale. Okay? So I measured up to 120. That's the measure of the angle, 120 degrees. The degree symbol looks like that, right up there. So you'll be asked to do something like that today and measure some angles. By the way, in your book, you notice that the actual rays that you're asked to measure the angles for, the actual rays are too short to reach your protractor. So I give you permission, if it isn't done yet in your book, to lightly extend the rays that are on those angles. Just lightly do that. It's the only time I let you write in your math book. But lightly extend those rays so that you can have them reach your protractor. All right, let's measure the angle of DEF. DEF. By the way, that's my wife's. Mrs. Frazier is holding the camera for this. That's her initials. Deborah Elaine Frazier. I said she's deaf. That's just a joke. Anyway, so that's let's measure that angle. Well, first thing, what I do is I take my protractor and I find the vertex and I choose the ray. I always try to choose the ray. I don't choose this one going up. I choose this one because I'd have to put my protractor upside down and all this. So I'm going to choose the ray that goes across like this. So I line up, I put the vertex there, and I lined up so this ray I chose, all right, ray EF, is hitting the 0. All right, so that's at 0, and it's on the inside scale, so I'm going to count using the inside scale, 10, 20, 30, 40. The other ray intersects the protractor at 40 degrees using the inside scale. So what is the measure of angle DEF? Right, 40 degrees. Now again, in today's practice, you'll be asked to do this on your own, and I know it can be a challenge at first, so don't get discouraged. Just look at this video over and over. You get to see me over and over. That would be just that's right there why you'd want to do it. But also you get to understand maybe as you hear this over and over again. Now, we can, besides measuring angles, we can draw angles. Let's suppose we're told to use our protractor and draw an angle of 70 degrees. a measure of 70 degrees. I'm going to call it whatever angle I want. Here are the steps. When you want to draw an angle, first thing is just to draw a random ray. All right, so I can use my protractor as a straight edge. I just drew a random ray. Doesn't matter. I always try to make them parallel to the ground. So that just makes it easier, I think. So I drew my random ray. Now I put the vertex on the end point. I point the ray at 0. And then I'm using the inside scale because the 0 is on the inside of this protractor. I go up to 70, 10, 20, 30, 40, 50, 60, 70. I put a mark there. So holding my protractor as still as I can, I put a mark up where the 70 is on my inside scale. Now I can lift my protractor off and connect the dots. That's all the points. So I'm going to start at the vertex and draw my other ray. Okay, so I can just call this angle C. And what is the measure of that angle? Well, it's going to be, as I just discovered there, 70 degrees. But that's all you have to do. Just draw the angle, give it a name. Let's do this one. Draw an angle. One more thing we're going to do, two things we're going to do, and then that's it for today. Draw an angle of 145 degrees. A little hard, right? But not difficult. First, what do I start with? A random ray. So, using my straight edge or ruler, it doesn't matter. You can draw your random ray. Now, I want to draw an angle of 145 degrees. So I'm going to put this as the vertex. There's the vertex notch. That ray I drew points at 0 on the inside, and I start counting up on the inside. There's 90 at the top, 130, 140, and using what's on my scale here on the protractor, I put a mark at 145 degrees. I lift this off now, and I can connect the points here and have perfectly drawn. Let's give this one angle D. So what's the measure of angle D? 145 degrees. Now again, you can watch this over and over and get this, I'm sure, practice will make perfect. Get your protractor, draw angles randomly, you will become an expert at using that instrument. So we've talked about what angles are, how to name them, how to measure them, how to draw them. One more thing you're going to be asked to do in the practice is to estimate measures. So let's look at this first one. I got this drawing here. Can you tell me any angle here that looks like it would be 90 degrees? What do you think? All right. Did you say angle BDA? Yes, I would think angle, let me put it up here, angle BDA would be 90 degrees. Now, how come I just didn't call it angle D? Well, there are a lot of angles here that could be called angle D. That's not specific enough. I want to say angle BDA. That's why we learn more than one way to name angles. All right, how about 130 degrees? Can you estimate which one would be 30 degrees? I don't think, if I'm looking at this, BDA, I would say 90 degrees. It makes a square corner. How about angle FDC? Angle FDC. So starting here, because 30 degrees, 45 degrees would be halfway to 90. So I'm estimating that's up to 90. So, that would be about 30 degrees. How about 135 degrees? By the way, some of these I'm giving aren't the only answers. There's another one that looks like 90 degrees on this. How about 135 degrees? Well, that's going to be over 90. So if I have angle, the vertex D, angle ADC is 90. EDC would be over 90. BDC would be 180. So I would say, how about angle EDC? That looks like it would be about 135 degrees. I'm talking about this angle right here. Ignore the other ones. I'm just going angle EDC. That angle right there is over 90, but it's less than 180. That would be about 135 degrees. In other words, I'm just estimating my eyeball on it and looking to see what it is. Well, that's today's lesson. Angles. We learned about what makes an angle. It's two rays with the same endpoint. We learned about three names for angles. We learned about how to measure angles using your protractor, and you can watch that again if you need to. We learned about how to draw angles and become an expert at that. And then we learned about how to estimate measures. Well, good seeing you.